Hello again. In section 7.5, we combine all these techniques that we learned in chapter 5 and 7, techniques of integration, of course. And let's look at a few examples and how to handle them. Let's say 15 on 522, we have the integral from x dx divided by x to the fourth plus 9. In this particular case, all I would do personally is just um, denote or let u equals x squared, du equals 2x dx. And of course, you know my style already. I just multiply by 2 and divide by 2. That's not going to make any difference. So we have du over u squared plus 9. And we can go ahead from this moment on. We've done this before. I'm just going to put the answer in. So it will be 1/6 arc tangent x squared over 3 plus a constant c. You saw this integral in a previous section. Then let's look at how we handle 17 on the same page, 522. Let's say this is a definite integral from 2 to 4 from x plus 2 divided by x squared plus 3x minus 4 dx. Of course, I see a rational function, degree of the top smaller than degree of the denominator. I will think of partial fraction decomposition because the denominator is factorable into x plus 4 and x minus 1. And I will say x over x plus 4 plus b over x minus a over x plus 4 plus b over x minus 1. I get b and continue changing that integral. I don't have to ever go back because it's a definite integral. So you're going to get a number. Let's say 19 on the same page, 522. Here we have the integral from 1 over x to the third, the square root of x squared minus 1 dx. So in this case, when I see this, there may be other options, but when I see this here with the square root of x squared minus 1, this is beautiful because I know that secant squared minus 1 will be tangent squared. So I let x be secant theta from the trig substitutions. Again, secant squared minus 1 will be tangent squared. The square root will be the square root of tangent squared, which is tangent. So I need dx, which is secant tangent theta d theta. So, I'm jumping over all this. And we have the integral from x cubed is secant cubed. We already discussed this. Secant squared minus 1 tangent squared. The square root is tangent x. Of course, tangent theta. And dx at the top is secant theta, tangent theta, d theta. These two go away. One of these disappears, but 1 over secant squared is cosine squared. So this is the integral from cosine squared theta d theta. And we remember what we do with this. We change it into a double angle using the double angle identity. So it's cosine squared. I'm on page 2. So this will be the integral from 1 plus cosine 2 theta over 2 d theta, and we continue from here. Also remember that you have to use that triangle, right triangle with theta, and secant theta is x over 1, or cosine is 1 over x. Cosine 1 over x. Of course, the other leg will be x squared minus 1. This is necessary for the final answer because it has to be in terms of x. Okay, let's also look at 41 on the same page, in which we have the integral from the square root of 3 minus 2x minus x squared dx. Of course, we have to think in terms of factoring. We have to think in terms of completing the square. So this will be 4 minus 1 minus 2x minus x squared. 4 minus 1 is 3, but all this is negative 1 plus 2x plus x squared, which will be negative x plus 1 everything squared. So therefore, We have here 4 minus x plus 1 everything squared. We have to factor out 4, taking the square root, so outside 2. So this will be 1 minus x plus 1 over 2 everything squared. And this is beautiful because 1 minus sine squared is cosine squared. The square of cosine squared is cosine. So then we have x plus 1 over 2 is sine theta. Or x equals 2 sine theta and then minus 1 because we need dx, which is 2 cosine theta d theta. So now, going back, let's try a different color here. I'm going back with a triangle. And so I created a triangle here because I already used this circle. So jumping over all this, let's see what we have. The integral from, there is a 2, so I'm going to put it outside. And again, 1 minus sine squared is cosine squared. The square root of cosine squared is cosine theta. But now I have to multiply by dx, which is 2 cosine theta d theta. So this is 4 cosine squared theta d theta. And it continues in the same way. And of course, don't forget, eventually we will have theta here. Sine is x plus 1 over 2. And this will be 4 minus this squared, which is, of course, is the given square root. 3 minus 2x minus x squared. This is necessary in order to present the final answer. Let's see if we can look at anything else. So I'm on page 3. So let's say 21 on the same page. And we have cosine cubed x over cosecant x dx. Of course, this requires some manipulation, algebraic manipulation. So we have cosine cubed over x, but this is 1 over sine x dx. So this is the integral from sine x cosine to the third dx. And we know when cosine is odd, has power, then we need the other one. So u equals sine x, du equals cosine x dx. Since they both have a odd power, I will definitely prefer u equals cosine x. So du equals negative sine x dx. And you know my style, I multiply twice by -1. I'm going to delete this in a moment. So negative, the integral from -1 sine with dx will be du. And this is u to the third. So this is negative u to the fourth over 4 plus a constant c, or negative cosine to the fourth over 4 plus a constant c. Let me erase this so there is no confusion there. Always try something. If you realize you're on the wrong track, just go back and try something else. Nothing wrong with that. If you have the summary of all the lessons that we had in chapter 7 on techniques of integration, you should be in perfect shape. I would like to, I think, look at one more. And we're going back to the book and see strategy for integration. There was, I think, yes, 20. I wanted to just show the beginning of 20, which is very simple. I would say the integral from 2x minus 3 over x cubed plus 3x dx. Well, what do we do with this? Obviously, it's a rational function. I always check degree smaller than this, so 2x minus 3. I factor x, factor of x squared plus 3. This is not factorable anymore. So we have an a over x plus bx plus c over the other factor, as you remember. Perform the technique, apply the technique of partial fraction decomposition, find a, b, and c, and then change the integral into two different integrals and take it from there. I hope this helps. Thank you.